Okay, so welcome everybody. My name is Gabriele Giammatteo. I work for engineering. In ICOS project, I was responsible for the overall platform integration and for the implementation of the monitoring subsystem. In this short demo, I'm going to introduce the ICOS Continuum, how it is built, and we will see how it's possible to create or at least to add some new nodes to the continuum. ICOS has been built to manage uh, computational nodes in the cloud edge continuum. So the idea is that we have many nodes spread across the continuum from IoT devices, far edge devices, near edge devices, cloud providers, cloud virtual machines, and we want a uniform way to manage all these nodes and a uniform way to monitor the nodes and to monitor the application, to deploy and manage all the applications. And this is for what ICOS has been built. As we can see in this picture, ICOS manage all the nodes that we call agents. So each agent is capable of executing user application, and there are also some additional nodes that we call controller that control portion of the continuums, and the lighthouse, which is a discovery service and contains or other central services like authentication, authorization, certification authority. If you analyze the agent is the interface between the ICOS model for nodes and application, which is abstract, to the real technologies for the orchestration of workloads. That can be Kubernetes, Docker Compose. In the project, we also experimented with OCM and NULA, which are multi-node, multi-clusters orchestrators. Um, so each agent needs an orchestrator, and the ICOS software will control the orchestrator, offloading the execution of user applications to the agent orchestrator. Now, since as we said, the orchestrators that we took into consideration are not single node orchestrator, but they can manage multiple node or even multiple clusters like OCM. We introduced the concept of the worker. So each ICOS worker is one of the nodes that is controlled by the orchestrator. Um, so, for instance, in a OCM agent, each worker is a cluster itself, is a Kubernetes cluster itself. An agent without a worker cannot execute any code because cannot offload the execution of the code to any node. So what we are going to do in the demo to showcase how to add a new agent and how to showcase also which are the components of the agent is to try to onboard a new agent in an existing continuum that we have in our testbed. So we will use two virtual machines to simulate the two nodes. So in one virtual machine, we are going to deploy the agent software and the orchestrator. In the other virtual machine, we are going to deploy the worker software. So we will first create the agent and register this agent to the continuum, and then we will add a new worker to this agent so that it will be able to execute user applications. So we can start logging into the agent node. Here, as I said before, the first step is to get a configuration for the agent. And in this case, I split the configuration in two files for convenience, but it can be merged in a single file. So the first part of the configuration is more generic, and this is valid for all the agents in the same continuum and contains information like the URL of the controller where to join, the root certificates for TLS certificates in the continuum, credentials to access to manage the certificates, the key for the identity server, the URL for the for the lighthouse. So all information that characterize the continuum. And then we have some more information uh, for 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 the agent, for the configuration of the agent, in particular the ID that we want to give to the agent, the identity of the agent with the username and credentials, and this is will be the identity that the agent will use when communicating with the other services, and the URL where this agent will be exposed. Plus, we have some other configuration for the agent, specific for some capability of the agent that we want to enable or disable. Something I want to highlight is that in this configuration we have some credentials that should be created and provided to us from the administrator of the continuum before we start the installation. This ensures that the our agent is authorized, so avoid for not authorized agent that join a continuum or malicious agent that join the continuum. So the administrator of the continuum has to be aware and to approve the joining of the new agent. And so this is an important step, initial step, uh, that ensure that a trust relationship exists between the ICOS continuum, the owner of the continuum, and ourselves. And while most of the operation of the agent later are automated, like the issuing of certificate, the renewal of TLS certificates, authentication, authorization, and so on. We wanted to keep this step, this initial step, manual, so that we can be sure that this trust relationship exists between the owner of the continuum and ourselves. So now we have two steps to execute in order to bootstrap the agent. The first one is to initialize the orchestrator, the OCM orchestrator in this case, because this is an OCM agent. This is a step that can be done also before, or the agent can also be deployed on a already set up and already established OCM cluster. But for the sake of completeness, I'm going to show this here in the demo. This is done. This we will need this later when we work when we add the worker. Now, what we want to do is to deploy the software for the agent. We are using the configuration file that we analyzed before, and we are starting the installation. As you can see, this is based on Helm. So the ICOS agent, it's an Helm chart that can be deployed and upgraded and maintained using a Helm. And this simplify a lot the maintenance of the software in the ICOS agent. Now, after the installation is completed, we can check this running the node, and we will see all the agent related components that are starting up. So we have components to interface with the OCM orchestrator, components to send telemetry data, components to manage the certificates, and so on. So while yeah, we finished to start up these components. Uh, the next step now is to configure a worker. As we said before, an agent without a worker cannot execute any code. So we log in the second machine now, and we will set up the worker in this virtual machine. Also, in this case, we need a configuration. Here we have a much simpler configuration. We just need the URL of the agent that we just created and the root certificate of the certification authority, plus some agent worker specific configuration like We can add some labels to the worker that can be used later by ICOS to in the matchmaking process, and we can enable or disable some specific features. Like in this case, I'm enabling this auditing capability that we will exploit later during the demo, in the deployment demo, to see how to enforce policies based on security. So also in this case, we have two steps. The first one is to set up the orchestrator. And in this case, we want the OCM orchestrator to join the orchestrator in the agent. And the second one is to install the ICOS worker suite. So concerning the first step, also in this case, we need a token. Also in this case, we want to be sure that not authorized workers cannot join the continuum, or malicious workers cannot connect to our continuum. So the first step is for the administrator of the ICOS continuum to create a token, a joining token. And we do in this way get token. So we create a token, and now we can, in the worker, we can join the continuum, request to join the continuum using this token. We give a name to this. Now the last step is that the owner of the continuum should accept our cluster, our new worker running this command. And after that, our worker became part of the agent orchestrator. The last step that we need to do is to install additional ICOS software to control the worker. And we do this by installing the ICOS worker suite as using the configuration file that we saw before. And we can check after the installation finished some of the components that are running in this node. In particular, we see the audit component. We see the components to monitor the peripherals attached to the worker. Components that collect system metrics or some other metrics generated by ICOS itself, and some other components for the security assessment of them. So from this moment, the worker is registered, is sending its telemetry data to the continuum, and will be usable for ICOS during the offloading of user applications. So we can verify this by logging in our monitoring system and to see the data that it's arriving from this worker. So we log in here with our credentials. We can check in the agent view dashboard all the agents and the worker registered. We can see that there are multiple agents in this continuum, and the one that we just created is called demo agent 1. The data that is produced by the worker, so it's registered, and we have the label that we set. We have all the information needed to ICOS for the orchestration, like the IP, the name, and the ID of the cluster. Plus, we have CPU, memory usage, disk usage, and other metrics that all of them will be used during the orchestration for optimizing the execution of the application. So in this continuum, we have also other agents with other nodes that we use internally for testing, and they will be used also in the next demo for for the execution of some applications. Here we have more information, of course, because these workers are running from more time. So we have multiple nodes. We have the security assessment informations. We have the peripherals attached to each to the different workers, plus the system information. Now, this concludes the first part of the demo, and we saw how it's possible to onboard an agent and a worker in an existing continuum. In the next step, we will deploy an application and showcase some of the ICOS functionality.